We have an excellent closing plenary speaker ready for you this morning. Dr. Vincent Tidwell is a distinguished member of the technical staff at Sandia National Laboratories. He's leading a multi-laboratory initiative supporting the Western Electricity Coordinating Council, the Electric Reliability Council of Texas, Western States Water Council, and the Western Governors Association to integrate issues of water and climate into long-term electricity transmission planning in the Western U.S. So this is sort of taking what we've been talking about, climate and resources that are impacted by climate, and how we can work together to help improve adaptation planning for these changes. And Dr. Tidwell is also lead author for the Land, Water, Energy Cross-Sectorial Chapter for the 2013 National Climate Assessment and supported preparation for the Southwest Regional Chapter. He's served on Governor Richardson's Blue Ribbon Task Force on Water. So I'd now like to turn over the podium to Vince to talk about his efforts. Thank you, Vince.
Good morning. Thanks for showing up today, and really appreciate the opportunity to come and talk to you a little bit about what we call collaborative modeling. Basically, the idea is trying to figure out how do we better engage stakeholders and scientists and others in decision making around water resources, other natural resources, and climate impacts. And so I know in many cases I'm talking to or preaching to the choir. I know many of you have had many opportunities to work with the public, work with various stakeholders around climate and other natural resources. So hopefully this will just be an opportunity for us to start a dialogue around some of our experiences, and certainly every case is a little different. And so we've got to stay flexible in the way we approach the stakeholders, engage them, and do decision making. And so I, for one, would be very interested in your experience as well. So basically the approach I'm going to take is open up with a few comments, and then go through kind of a shotgun approach to a bunch of the projects that we've worked on over the years, and hopefully draw a few conclusions and experiences that we've had. And first off, I just want to say I've been very blessed over the past 10 or so years working in this area to have a great group of folks at Sandia National Labs, as well as across many other agencies and universities and other organizations to work with us on these projects. And this is just a small list of the folks who've been very instrumental in this work over the years. And so what makes these problems so difficult? Well, I bet all of you are aware of these. It starts with the fact that demand is growing. Demand is growing for water for our communities, water for thermoelectric power generation, water for agriculture, many other areas. If it wasn't growing, we wouldn't really have much of an issue. The other thing that makes this really an interesting problem is the fact that all these systems are interrelated. So as I need more water for our homes, that same water requires energy to move and treat the water. And so we've got to understand all of these relationships and how these things fit together. And then anything we do has an impact on the environment, and so what is the relationship between the environment and the activities that we're doing in the anthropogenic sector? And then there's all kinds of uncertainties, not just about how we may grow and how the different sectors will evolve over time, but also we have climate change and how that may be changing over time and to what extent it may be changing. And so that adds this high level of uncertainty throughout everything that we do. And then finally, if all this wasn't enough, it's dealing with all the different values that we hold around the natural resources, how they should be allocated, how they should be used, and just different values about what's important. So how do we get around all these issues? How do we come and find some common space to make decisions about? And so as I was thinking about this, I think, if we could just get to the point where we learn to speak the same language, I think we would be in a really good position to start making some real good progress. And I think we have made a lot of progress over the years, but it's because we've begun speaking the same language. And part of that is understanding that we all have important things to add to the analysis, that all the stakeholders bring some kind of experience or data or information that's really valuable to the process. And the more we understand that and value it and bring it into the analysis, the better off we are at the end of the day. The other side, though, is that no single person has all the knowledge or knows everything, even though that many times I find that the case, that there are a few who think they know it all. But it's recognizing that we really, no one owns all the information. The other is that, we need to be developing some kind of shared basis for decision making, shared tools that we all have trust in, we agree on, and can engage over. And once we get there, I think we're in a good position to start making decisions. And so there are 4 things here that I want to mention that I think go into helping us speak that common language. And there are many other things, but these are 4 that I found that I think are particularly important. The first is we've got to have tools, integrative tools, interdisciplinary tools. And these problems are just too sophisticated, too hard to use intuition alone. So we need mathematical models to help look at the problem. And there are many different kinds of models. There's no single model out there that we have to use. We use a lot of systems models, but sometimes you need high fidelity models to answer some of the questions. And sometimes these high fidelity models need to be interconnected and work together. Other times system levels models are needed. Or sometimes you need the high fidelity models at regional planning, but system level models to bring that information to a higher level or to be able to present it to the public. The other place is it's not good enough just to have the models. You can have the most sophisticated model in the world, but if no one trusts it or no one can use it or figure it out, it's not really worth anything. And so one thing that we've found that really helps with this process is to bring the stakeholders, the public, whoever it is that's going to be in the decision process in very early in the process, right at the beginning. So you begin developing your model based on the right questions. What are the right questions that we need to be answering? And then work with them throughout the process to gather the data, to develop the causal relationships, to understand the conceptual model, and then to develop the scenarios that you're going to be working with. So just as we show here, the causal loop models down on the bottom, what are the causalities, and then up to some kind of numerical model. And all that's done together with the people. So it takes away this black box mentality of, our model's this black box, you can't look in it, but rather they help develop it. That develops consensus, that develops trust, but it also takes a lot of time and it's frustrating as well. But this is part of the process that Pat was talking about earlier yesterday, and the fact that you've got to start developing trust. You've got to start developing a team of folks who can work together and who trust each other in order to make these kinds of decisions, and that is key to this whole process. The other is, I think, that really helps is the more visual, more interactive you can make these tools and the process, the better off you are. Some ways of learning together. And so the idea here is that, user interfaces where you can, punch buttons or move slider bars to enact different kinds of policies and then get almost real-time, immediate feedback on the results. And so you can see it, you can learn from it, you can test different what-if situations and scenarios and see what difference it makes. So providing this kind of interactive environment. And then lastly, and again, this is not an exhaustive list, but motivation. Unless there's motivation there for people to work together and come to a decision, you might as well just close up camp and go home. And I've found this on a number of occasions, and basically what it has to be is that people have to be more afraid of the future and what could happen than the changes that are required to the status quo. So until they're more worried about the future than they are, holding on to whatever it is they have right now, you're not going to move very far. So motivation is key in really moving ahead with any of this. So now with that in mind, and again, that's not an exhaustive list, but some ideas of what I think are really important, or I've found to have been very important in our work. Now I want to go through a few examples and basically kind of talk a little bit about the models, the integration or interactivity with the stakeholders, this motivation, as well as give you a few examples of the interfaces that we've built and how we interact through those interfaces. And a lot of it revolves around the Middle Rio Grande because it kind of shows a maturing of our work there over the years and how it's evolved and some different ways of thinking. And so this all started about 12 years ago for us throughout New Mexico. They had the state engineer applied a statewide water planning process, broke the state into 15 or 16 different basins. We worked with the Middle Rio Grande Water Assembly, which was a 3-county region here in the middle of New Mexico. Albuquerque's in there. The Rio Grande runs right through the middle of it. And this was some work that Howard Pacell, also at Sandia, worked real closely with me. We worked with the water assembly there in Albuquerque. And here, the whole idea was really just balancing the water budget. This was really before climate was a big deal, but you know, the precursor to all this is we've got to get our system organized before we can start worrying about climate. Right now, we're totally over-appropriated anyway. So the idea is, over the next 50 years, how do we balance that water budget in an over-appropriated basin? The process, again, so this is that kind of collaborative modeling, this interaction that we were talking about. We developed what we called a collaborative modeling team. We met roughly twice a week to develop this model. On this team were folks from the water assembly, so those were urban developers, environmentalists, farmers, etc. We also had government officials. The Regional Council of Governments was involved. We had professional facilitation with this, which is very important. It really helps. In this particular case, the professional community, the agencies were not terribly involved. We worked with them to gather data and understanding, but they weren't intimately involved in this process, and that's just the way it was set up. We also engaged the broad community through all kinds of you know, outreach, public forums, education venues, schools, and stuff. And with that, let me show you, you know, a picture, as they say, is worth 1,000 words. Many of you have probably already seen this, but just to give you an idea of what some of these interactive interfaces look like, and again, this is a very old example, but it's still one of our nicest interfaces that we've done. These do take a lot of time to develop, but the idea is you create this interface you can go through, you can learn all about the model, all the assumptions, where we went to go get the data. We actually have, I have to put my glasses on here. So this is a system-based model. It's built in System Dynamics. PowerSim is the particular modeling software that this is built in. But see, the idea is how fast the model can run. It's based on you know, mass balance, commodity balance, and here we've calibrated it here to the Rio Grande compact balance on top. The blue line, the red is the model. All those model runs run from what, 1950 out to 2050. So 50 years of calibration, 50 years into the future. This is kind of the baseline case if we do nothing. Santa Acacia flows, these are Rio Grande flows down below our planning region, Elephant Butte storage, it's the major reservoir below our planning region, and then our groundwater depletion. So basically, at a rough level, we're able to calibrate our model to historical data, again, at a pretty high level, annual time step model that we have. And so, you know, where we would start with the stakeholders here is, well, this is the baseline case. If we did nothing, this is kind of on average what we're looking at, you know, impacts on compact balance. We aren't likely to be able to meet our compact balance. Why? Well, because, you know, the city is going to be continuing to grow. The climate is going to moderate. The last, you know, in the 80s and 90s were some of the wettest in history. So everything we can see, we're likely to be running some kind of deficit. Also, we already know, we've seen the groundwater levels in Albuquerque dropping is over here on this side. So you can see that you know, we've had these drops. This little inflection point is where the city actually begins to take action, and they have, starting to use the San Juan Chama water. But even if we don't do some cutbacks, you know, we're likely to be back in the same problem again. So what can we do to help solve this problem? Well, there are all kinds of different options that the public came up with. So we worked with them, things like low flow appliances in the homes, thinning out the bosque, the riparian area along the river, changes to agriculture, drip irrigation, lining ditches, etc. So the idea is with a tool like this is you can go and then compare these different measures. So like for residential, this is an example I usually show, which if we went in and put in low flow appliances, if we're able to get 60% of the people to put in low flow appliances and require that in all new home construction going forward, same thing in all of our commercial buildings, and that's kind of a high level, but you know, let's shoot for the stars here and let's see what the impact would be. So the red line now is if we could enact that one piece of policy. You can see roughly what the cost would be here. Here's for retrofitting all the homes, and this is kind of the latent costs in terms of all new homes being retrofitted or being fitted with low flow appliances. This is cost per acre foot. Here, as you would expect, because the city of Albuquerque gets most of their water from groundwater, at least well, the region does, and even the city still depends a bit on groundwater. We see that as we use more low-flow appliances, so we use less water, we're taking less water out of the aquifer, so we get a little improvement here in terms of our drawdown. It's not enough, so we're going to have to do something else to get it to a point where it's sustainable. But the kind of the unexpected result for many people was the fact that, well, we end up with less water in the river. And so the question would be, well, what in the heck is going on? Well, many of you who know something about Albuquerque, you probably already know what's going on. But the fact that we've got less treated sewage return flow, so basically we're taking a lot of water out of the groundwater and returning it to the Rio Grande. So if that water is not being returned to the Rio Grande, we have a problem. This gap is pretty big, though, so that seems bigger than the changes we were seeing to the compact. Well, there's something else going on which is in opposite to it, and that is we're getting less leakage from the river because we're pumping less. So, but the balance between the two ends up with a deficit because the sewage return flows are a little less than the reduced leakage, and so we still end up with a net deficit. So the idea here is you get an idea of, well, here's part of the impact of the city and what they could do to help improve things. We can reset this and rerun and say, well, what if, well, let's do Bosque, what the heck here. So if we went in and thinned the Bosque, this is something that almost everyone would agree upon, is saying, you know, for fire purposes and just recreational and everything, if we could go for all the land, public lands along the river, what would happen if I went in and thinned out the forest along there? And so here you see there's really no impact on our deeper aquifer, right? It's mainly shallow aquifer, the river, but we see a nice improvement here in the river. So the idea is that, but still again, it's not enough to get us up to our compact balance. You can see a different cost here, a different cost per acre foot saved. So the idea is you can go through, you can kind of learn in kind of apples to apples terms is what is the overall impact? How do these different actions that I could take, how do they line up with each other? Which is more important? Which do I get a bigger bang for my dollar? And then how many of these, as you can see, no single action is going to take care of everything. We're going to have more than one action. And so everybody's going to have to share the pain a little bit. And so I think for all of these reasons, this kind of tool was very useful for folks to begin to understand in a high level at least what the trade-offs were, okay? So again, this whole tool was built in a system dynamics framework, fairly simple, one big bucket for our whole planning region, but very complex within that bucket, and then you know, a daily time step. And so the motivation there was high. We had to get a plan out, so we got the plan. The model was a big help to developing that plan, played a very integral part to that. And over the years that a lot of these actions have been implemented. And so for all those reasons, I think, you know, there was quite a bit of success in that effort. There we go. So in fact, what was really interesting is that after we went through this process, many of the federal agencies who, you know, were responsible for management of the river came to us and said, we really like your idea, but we don't like your model too much. It's just not complex enough or detailed enough to answer a lot of the questions that we're really interested in. And so could we try the process over but make the model more complex, and how more sophisticated do you think we could make it and still be able to take it out to the public? And so this started a new partnership, and again, I think it's kind of like Pat was talking about. This is a long-term effort now that we've been working with the Corps of Engineers, Bureau of Rec, the State Engineers Office, and the USGS. We're probably about 7 or 8 years now in developing this new tool. Jesse Roach has been very instrumental in developing this at Sandia, along with these guys. And what's really kind of interesting about this, so a little bit of different stakeholder team that is involved in this. The other thing is that, again, we're using a systems level model, system dynamics, to build this model, this integrated model, but now it's designed to sit on top, if you will, of all these more sophisticated models. So the multiple mod flow models within the basin for groundwater management, a riverware model that manages the surface water and river routing and reservoir operations, ET Toolbox, which does all the evaporative demand modeling. And so the idea is we've calibrated a model to all of those that is fully dynamic, operational all together, unlike the tools that they currently have. So the idea here is that we have the system level model on top of all these other very more sophisticated models, the idea being that we can run lots of simulations, we can do scenario analysis, we can go out to the public with it, and then when we find some scenarios we like, we can then go back and do the high fidelity modeling with the other tools, but only a few, because that's all we have time for, right? So that's the kind of idea. So basically what we've done is we've modeled the whole upper Rio Grande. So from the Colorado border, in fact, I think Jesse has extended it now into Colorado, or is in the process of, down to Caballo Reservoir, which is in the southern part of the state. Also, the Chama is modeled in here, part of the Jemez River, for those of you who know. So 17 different reaches based on the different gauges along the river. 7 different reservoirs, all their operational rules. 3 different groundwater models. So each of these 3 models are individual mod flow models that we've abstracted to our case. And so the idea is all these are dynamically linked, plus all the demands. So irrigation systems are separate. All the water pumping, municipalities, etc., all those demands are in the model as well. Again, same physics as in Uruguay, the Upper Rio Grande Water Operations Model, the Riverware model, except now we're operating on a monthly basis instead of a daily basis. Again, same thing with ET Toolbox, so instead of it, same algorithms, just different time resolution. Mod flow models, again, 3 of them that we've all integrated into the same model, but instead of millions of nodes as in the Middle Rio Grande, we've simplified that down to about 50. But you can still see where Albuquerque and Rio Rancho and some of the key areas are within here and how they're affecting the overall groundwater drawdown. And again, it's all linked dynamically to the river and the irrigation systems, etc. So again, we're able to put an interface on it so you can, not quite as fancy as what we had before, but the idea is you can still play out these different scenarios very quickly and see what the impacts, again, are on the compact balance, so what water we owe to Texas and Mexico. Changes in groundwater heads, this is the Espanola Basin, and in fact, leakages from the river, how it affects the different reservoirs in the area and what the storage would be, how it affects our ability to meet in-stream flow demands for the silvery minnow, the endangered species there. So since that time, there hasn't been a lot of motivation to act on the Middle Rio Grande. It's just too big, too complicated, too expensive, so largely we've ignored it to date. But the idea is that we've created this team with a lot of trust. We've begun developing tools that are ready to address the problems when people are finally motivated to act on them. In the meantime, we've done all kinds of work with the Corps and Bureau and others to look at various problems, including the silvery minnow, but these are brand new results that I think are a little scary. So it's a little bit like the Colorado River study that was done. So this is work, again, that Jesse Roach and Dagmar Llewellyn from the Bureau of Reclamation have very recently done, but they basically took that model, that systems model, and they ran the 112 GCM models, the downscaled models that have, again, through VIC, they've calculated what the runoff is from these 112 GCMs. We've taken that data, which are basically the inputs to our river routing integrated groundwater model, and to see overall what the impacts are on deliveries, flows, etc. And so what's nice about, because the model runs real rapidly, where they can't do this with Uruguay and ModFlow and all that, because they're not connected to begin with, we can run all 112 of these within about a day's time, or even less than that. And so here you can see the blue line is the average, and then these different colors have to do with the range within the variability of those 112 models. So here, these are the flows, the average flows, starting back in 1950 out to 2100 of what we would see in terms of the inflow from Colorado into New Mexico. And you can see this line's going straight down. So a big change, almost a half loss, 30 to 40% change in flows expected at Labados if these GCM models are correct. The other thing we would expect down here is how the hydrograph is changing over time. So much earlier runoff, lower runoff overall, as we would expect. Also, of course, the ET for agriculture, ET for municipal use are all expected to go up, which further compounds the fact that we don't have as much supply that we're starting with. This all adds up to less water in our reservoirs, so Elephant Butte basically almost empty after 50 years from now. Heron, which is very important again because it's where they store the water for the San Juan Chama project, which is where the city of Albuquerque gets most of their water. So again, you can see this tanking and being a potential problem going forward. The really important one is the compact balance. And so you can see a very steep decrease that even under most cases, we're looking at a pretty large deficit. And, you know, Texas won't allow this. They will sue us. Well, actually, they're already suing us, so I don't know if it's a big deal. But this can't continue, so we'll have to do something about it. Also, the deliveries from the San Juan Chama water project are expected to decline. So the city of Albuquerque is going to have problems as well. So we're all in this together. Maybe this is something we got to start taking some action on. These are brand new results. The report should be out a little later this summer. So anyway, again, this is a project where, you know, we've been developing trust, developing this team of folks to be prepared when these problems really rise to a point where people are really ready to attack them. In the meantime, we've been looking for some other options of ways we can adapt to climate and just overuse, over-appropriations of the basin. One of these areas is through water marketing and water leasing in particular, or water leasing market. And so this is in particular some work that I've been doing with David Brookshire and several others over the years at the University of New Mexico. And so basically here what we've done is taken our hydrology model and we've put an interface on top of it that allows people to play within a water leasing market. So the idea now is the way we engage stakeholders is kind of in a game where they can sit down. We'll invite 15 or 20 of them in at a time. They play either farmers up and down the basin, or they play like they're the water manager for Albuquerque and he has to get water for the city, or environmentalists who need to make water available for in-stream flows. And the idea is that, you know, the hydrology model informs this and says, okay, there's not enough, or this is how much water you're going to get this year, or that's what we think you're going to get. Then they have to go in and they can play in the market. Here you can see here are the different players in the market, and you can see some of them putting out bids to buy or lease water. And so if someone sees that and they like it, they'll take that, and they go through and they play back and forth. Some people may decide, I'm just going to sell out my water because it's better for me. Other people say, I've got to buy the water. And so we see what happens overall. And from there, we can begin to see how this affects movement of water up and down the river. We see how it impacts the gains and losses by the different individual players. Are people better off by being in this market? And also, what are the prices doing and how do they behave in terms of what they think they should? How are people behaving in this? How are they trying to game the system? And so we can learn a lot from this. So the idea is this is a virtual laboratory where people can come together and begin to design a water market that works for them. And in fact, the state engineer was really impressed with this. He liked it. So we went out and worked with the Bureau of Reclamation through their Water Smart program. We got some funding, and we're now doing a project in the Mimbres River, which is down in the southwestern New Mexico, where all the rights are adjudicated. And we're working to kind of develop a template for the state for water leasing and then to apply it there in the Mimbres Basin. This is a particular project. It's further out from any kind of real application, but it's more of an idea at this point. We've kind of taken it a little bit of the way, but the idea here is, so we've been working with these system models or physical models up to this point. Now we're looking at the idea of, well, what about the behavioral component? Of course, now we're trying to bring in some of the agent-based models to capture behaviors of humans and how they interact with the environment. But those agent models are pretty difficult because, you know, it's hard to figure out how do we quantify and how do we parameterize those agent models. And so the idea is to bring in kind of an interactive gaming component where we can learn from the way people play the game and then use that to build autonomous agents within the system. And so the idea is you have your system dynamics or systems level models that are the environment, how much water is there and how is the hydrology changing, like what I showed a moment ago, and the economy and other things. And so that provides cues to your agent model over here where the people are saying, okay, I've got this much water, this is the price of corn and wheat, or here's how much I could get from a lease, and they make decisions. And then that, again, affects back how much water there is and all that kind of thing. So, but the idea is that we have these gaming environments where they can go in, they play the game first, and we learn from that. then we create agents that look like the way they played the game. And then from that, you can see this, circular process, iterative process of developing a tool. And so this was a project we did with Intel, and they had some open source gaming environment that they were wanting people to use, so we worked together on this. This is actually an immersive environment. So I've got a little avatar. I can go in, walk around in my fields and my, city and everything else, and get a feeling for what it looks like. Now these are hard to develop. I'm not going to stand up here and lie to you. This is really hard work. It's expensive. It's time consuming. We only got so far on this. But the idea is that you could play different types of people. So I could either be a farmer, a developer, build houses, or I could be a manufacturer. And so the idea is that you start the game with a little bit of money, and you go out and you buy a piece of land, and you decide, what role you want to play. And then depending on what you are, you could decide, I'm going to plant these different crops. And you have 3 different crops. Some are cash crops, some are perennial crops, so grapes versus alfalfa versus chilies, I think. And so you can decide then how much of your land you want to plant. And depending on the crop, some of them take multiple years to get to maturity before you start making money from them. And so each year you have 2 rounds. One is you plant, and then you decide how you allocate your water as the second round. Same thing with your developers. He buys a piece of land, he starts to develop it. He builds different houses, different kinds of houses with different expenses and whatnot. And it takes multiple rounds. You can see that kind of floating shovel here. That means he's not completed yet. So these are still in, building phase. And so they go through the game this way. And so over time, things change. So there's less water, or the economy slows down, and the guy gets trapped with a bunch of houses that he can't sell, or grapes that they can't sell, or whatever, or not enough water. And so the game's already set up where the developer can't develop until he gets water from someone. So they have to interact, sell water and resources and et cetera. And so again, we can view how they're playing. And so again, a different way of a whole different set of tools that we're using, a whole different set of ways of engaging people in the games. And really, I think where we were going with this too is the idea of, instead of having the stakeholders come to us and run the games, we're now going out to them. This would all be web served, just like your kids now, the Warcraft and all those other games they play. Well, the idea is that this could be one of the games, and it would be a lot more fun than sitting in a meeting like this and watching me go through these kind of models, right? So hopefully going out directly and getting people engaged. So now we're kind of getting smaller and smaller. Now we're focused just on some of the tributaries on the Rio Grande. And this is actually put a plug in for EPSCoR. This is one of the wins I think we had this past year, where the team that started off looking at acequias, we actually spun off a project to NSF, the Natural Human and Coupled Human and Natural Systems programming, and were awarded a 5-year project to look at these acequias. So acequias are more than just these irrigation ditches that run throughout northern New Mexico. Basically, they're these community managed irrigation systems, but much more than that. I mean, they're the way of life. So, the Spanish brought these in when they migrated here to New Mexico. And the interesting thing is, so not only is it a ditch, but it's also a whole water management system in and of itself. And it comes with, a culture of bringing the community together around to manage these. It brings the folks together in terms of cleaning the ditch, and even their festivals and stuff all revolve around these acequias. And so what we're doing is we're working with 3 different communities in northern New Mexico and the watersheds that are associated with these small irrigation valleys, because these upland areas have historically also been used for grazing, and we're trying to understand the coupling between the grazing and the irrigation downstream as well. So really complex systems. And so really what we've learned, I guess, and so here's a kind of a different stakeholder model in a sense, is that where we had to start is just learning how to talk together within the team. So we had a variety of anthropologists, economists, hydrologists, ecologists, geologists, all trying to work together, and none of us speak the same language. And so those of you who've done interdisciplinary efforts in modeling, it's hard to get to where you're speaking the same language. On top of that, the way sociologists and economists often quantify their models is very different than the way I, as a hydrologist, would quantify and think about the way we would do modeling. And so what we've been doing is working first with the team to develop these causal relationships in these key systems and thinking about how they all relate to each other. And so we're coming up kind of with our conceptual model, the causalities and stuff, what's important. And then also working with the public to understand, and we've been going out to these communities and understanding how they have reacted and how they've changed over time with climate and urban growth. And now we're going the next phase, and we're collecting data through surveys and all kinds of focus groups and other things, so we can now quantify the rates and the stocks and other things that go into our model. And so that's kind of where we are now, but the idea is to understand how they've reacted to climate change or just drought in the past, and how they've reacted to urban growth, and then looking forward, how do we help them to be more resilient? And so this is an issue not just for Acequias, but all kinds of rural communities around the United States. So the final project I want to talk about, we're finally jumping out of the Rio Grande Basin and looking very broadly. Now we've gone very different scale. And really kind of a different problem now is, and I think what's kind of interesting about this project is the first time where we've actually brought people from the electric transmission planning community together in a big way with the water managers in the western United States. So we're working with the Electric Reliability Council of Texas and the Western Electricity Coordinating Council, so they're the ones that bring all the different electric utilities together and help them do their long-range planning. And so we brought them together with the Western Governors Association and Western States Water Council. That's all the state engineers around the western U.S., and DOE is funding this effort. And so the idea is to help WEC and ERCOT do their planning. Where do I put the next power plant? Where do I put the next transmission line? And how do I do that in a way that I'm conscious of the water issues? And also to look at my existing portfolio. And so I'm supported by a bunch of different national labs, the University of Texas and EPRI in this effort. And so here's WEC, you can see out west here. And so we're mainly just focused on the United States part of WEC, and then ERCOT's here most of Texas. And so we're working with these guys, and you know, the electric guys, they have a lot of other things to worry about. They got to minimize cost, because you know, we don't want to see a big, huge jump in our rates. They also have to worry about reliability of that system, of course, and then you know, they want to maximize their transmission capacity utilization. So there's other things and all kinds of policies they got to worry about, that you know, RPSs and emission controls and other things that they have to deal with. So water is just, you know, one other thing, one other headache they have to deal with. But at least they're willing to work with us for the first time in really bringing this in I think, an important way. And so the first thing we had to do is just figure out how much water does a power plant use. And so here, I know you can't read all this, but along the bottom here are all kinds of different power plants: coal, natural gas, combined cycle, natural gas steam, solar thermal, etc. So you can see these lines, these are kind of the range of, I think this is a CSP plant. So you can see it uses quite a bit of water, but there's a range here. Here's a coal plant. Here's a natural gas, range of natural gas plants all around the U.S. using recirculating cooling, so different kinds of cooling systems. These are the big cooling towers that you see. Here's open loop cooling, where it just goes into the plant and back out, or dry cooling over here, which doesn't use much. So we've gone in and characterized this, and then we're able to map that out for the western United States here. And so here you can see that, you know, where all the different plants are and which basins at a Huck 8 level, or, you know, and how much water is being used. And you can see the highest use is right here in the kind of the Four Corners region. Why? A lot of coal, right? So a lot of coal plants. But along the coast here, you can see a lot of plants, but not as much water use, because a lot of them are renewables and natural gas. Texas has a fair amount of coal, fairly high water use, but a lot of them are open loop too. So again, quite a bit of variability where these existing power plants are. What we also have to worry about is these plants. What about climate change? And so we've started with a study in Texas where we did basically just like I talked about with Jesse and the Middle Rio Grande, where we took the climate models, ran them through, this case we used SWAT, to look at the impacts on the reservoir system in New Mexico, in Texas, and because this is where the reservoir or the power plants get their water. And so the red basins are where there's likely to be trouble over the next 20 years. This is the worst drought we could find. In fact, it's only slightly worse than the 2011 drought that they've already gone through. A little bit different shape to which basins are impacted, but the idea is what they wanted to know with future growth and climate change, how bad might drought get. And so the other interesting thing is that we couldn't reproduce in any of the models we looked at a multi-year drought. which looks like they're getting ready to rerun, right, this year with at least the way the lakes are looking, it looks pretty bad. But nevertheless, we reran the 50s with future water demands to see how the impact would be on different reservoirs, and then related that to intake structures to identify which power plants might be at risk currently from future drought. The other thing is we built a little model here that takes in ambient temperature and heat rate and all the other things that have to do with the effluent levels, the temperatures for the power plants, the open loop plants are the ones we're concerned about. The red line is the EPA limit for the discharges of these plants. And then we're able to look forward and see which plants are likely to exceed their EPA standards. So we'd get an idea of how much production might be curtailed. So this way we're looking at the current fleet and seeing what the impacts might be. The final thing that we're doing is also looking at availability of water for future development. And so we've characterized 5 different sources of water, which I think is a little unique. Unappropriated surface water, so if I can get a permit for it just from the state engineer. Unappropriated groundwater, which is the same, I can just go out and get a permit. Appropriated water, which is I'd have to buy it off a farmer or someone else. Then non-potable water, municipal, industrial wastewater, and shallow brackish water. And so we've gone through working with the states to get the availability and cost. And so basically we work directly with the states to collect all kinds of data first. Because I mean, nobody can give me just unappropriated groundwater. States don't tell me that. So we had to collect a lot of data, work with the state managers to put that information together, and then come up with these different measures of water availability. So very, collaborative process. We're currently vetting these final answers with everyone, but you can see these different sources of water. Here's unappropriated surface water. As you can expect, there's very little in the Southwest available just to go, and unappropriated water, even groundwater. So the colors here, this is all at Huck 8 level, so about 1,200 watersheds. Blue is quite a bit of water, over 250,000 acre-feet of available water. Red is, white is 0. And green is just roughly enough maybe to start with kind of a medium-sized power plant of like a gas or small coal plant. So you can see all this wide area, no real availability of unappropriated surface water, lots of big gaps in groundwater. Here is appropriated water. So you can see it's pretty evenly distributed all over, but we've limited it to about 5% of irrigated ag. So there are a few places, where there's a lot of ag, like here in southern Arizona, some in the panhandle of Texas, Snake River Valley, the Middle Valley of California. Here, wastewater, we've tried to remove water that belongs to someone else downstream, but again, very kind of hit or miss because of that, except around some of the big cities, there's availability. Brackish water, shallow in this case, down to about 2,500 feet. And then these are projected from the states, the future demands. And so you can see a lot of wide areas here. Red is high in this case, so around Phoenix, Tucson, here in the eastern part of Arizona. But you see a lot of wide areas. These are places where the states are actually saying we expect demands to decrease because of abandonment of irrigated ag. Again, this is all state data if they had it. And then if we put it all together, again, just the unappropriated water, we got big gaps, all these wide areas. But if we put in all the water, there's water out there. But the big issue is at what cost. And so we've also mapped out the cost of these waters. So this is for groundwater based on its depth. Here's what people have historically paid recently for water transfers. Here's wastewater costs to lift and to capture and treat and even buy the water. Here is for lifting and treating the brackish groundwater. So you can see order or so of magnitude greater cost with the brackish and wastewater. And so the way this works is then now we got to bring all this information together and deliver it to our partners at ERCOT and WEC. And so they're creating these models where looking at dispatch of electricity and where the nodes are, where the power is being generated, where they need power. And so how do we bring the water into the problem? It's basically a cost and a constraint on the model. So they're doing this kind of in an optimization, multi-criteria optimization model. So what we've done is figured out, we can create a supply curve for every one of those little Huck 8 basins. Here I've aggregated it up to the state level so you can see it pretty easily. But basically these are just simple supply curves. And so for the different states, you can see that, Wyoming has a lot of pretty cheap water out there because, there's still a fair amount of unappropriated surface water, and then it gets expensive. Whereas Arizona, almost the next drop of water is going to start at a pretty high cost, as you'd expect. So the way is, this is the transfer point. We can transfer this information, and this is what they need to constrain their modeling. So a little different approach in that. The other nice thing is, again, what about the interface? So here, this has been a really great collaboration with the Western States Water Council. They're going to make all of this available. And so all of these maps I've been showing you are going to be available and tied directly to the states to the extent that they keep that up to date. We will be updating it in our data and our metrics so within this interface, and so you'll be able to access all of this information going forward and develop your own metrics if you don't like the ones that we develop. So that is, in a nutshell, all the different kind of projects and a few of the experiences that we've had going along. Again, all revolves around, I think, learning to speak the same language, the modeling that you need to have, the collaboration that's key to it, the visual aspects in terms of the way we interact with the data, the motivation behind making these things happen. Again, this is not an exhaustive list, and every example is a little different. There's no single way to do any of this. And so for those of you who might be interested in collaborative modeling, we've developed or in the process of creating a community of collaborative modelers. And so this is something we're doing with the Corps of Engineers and the Institute for Environmental Conflict Resolution out of the University of Arizona. And so the idea is that we've been having meetings. We've had 3 so far. We've got a 4th one planned. It's going to be with the American Water Resources Association annual meeting in Portland in November. So if you'd like to be involved in that, let me know. We're looking for other people to participate with us. We've had 50 to 100 people the last few times doing this. And we've also come up with best practices and metrics of success and a lot of other kinds of information. I'm sorry I don't have the website here, but I can get that for you if you're interested. So with that, I will quit. If there's time, I'm happy to answer some questions. Thank you.
And a very apropos talk, I think, for this audience, pulling a lot of thoughts and pieces together. So thank you for joining us. And yes, we will take time for questions. So if anyone has a question, please come forward to the microphones. Yeah.
Yeah, my name is Jay Liu. I'm from University of Idaho. Actually, I'm very impressed in the research you are doing. So I noticed many local stakeholders get involved in the shared vision planning process and the system dynamic framework. So, but if they have ample water condition, nobody worry about water shortage because they're gonna happy about it. But in case of drought, it seems to me they might compete against each other to secure water resource to meet their demand target. So I definitely maybe water conflict issue rise. So my question is, have you faced such a water conflict issues among the local stakeholders group, and what kind of resolution strategy you have taken to resolve that issue?
Sure, that's a good question. And I guess, so all of these cases to some extent have been, a conflict or a conflict in the making. So basically you're trying to figure out how do we allocate or manage the water in such a way that people feel comfortable and it's fair, et cetera. So, and I think that's behind this whole collaborative modeling idea, is that basically you're getting folks together, you're helping them first to create some tools that they have trust in, and then again, that gets back to the motivation. Once the people have been working together, they realize they're all in this problem together. They all have a shared part in the problem, and that's kind of where the example I was showing very first from the Middle Rio Grande. Part of that was understanding that the reason that we're in an overdraft condition is not because of just the city or just because of the irrigators or just because of the bosque or whatever. It's everybody's problem. Everybody's contributing to it. And it also will take everybody to get us out of the problem. And so, and what they can contribute to helping to improve on that problem. And then hopefully by understanding, as they gain a better understanding of the system and where they fit within the system, they understand you know, what the benefits to them are and the fact that they need to cooperate because, you know, their future depends on the other folks' future. So all of that together, but I think at the end of the day, what's really important is that most of these issues, when I come to the table with them, they realize they need to compromise. And I think in most cases, they're willing to compromise. But where the problem comes in is they're worried they don't want to compromise too much. And they want to make sure that compromise is fair. And that's where the real issues and why the modeling is necessary to try to figure out what's fair. And also in getting people to talk. And that's the only way you get there.
Hi, thank you for your presentation. I'm Janice Varela from the New Mexico Acequia Association. We're a statewide advocacy group that work for farmers in acequia communities. And I'm curious about how the state engineer looked at this modeling project and the Mimbres as far as leases versus permanent transfers. Because my understanding is the state engineer's office is more interested in a community securing a permanent water right through permanent transfer rather than a lease. Did you come across anything with your experience with the state in this modeling, and how is that changing, or might it change?
Sure, no, excellent question. And so actually the state has the new active water resources management structure, right? And the idea there is that, you know, the state recognizes that there's many areas in the state that are unadjudicated at this point. So he needs a plan for being able to go in and work with these unadjudicated basins, which is not the case for the Mimbres, but in many other cases. And so that's been a problem. But the idea is that you figure out who owns what right, what water at what rights, and then from there you can begin deciding, you know, in times of drought, in times of problem, and this is really where we're looking at the lease, is that we need mechanisms for rapid transfer of water from the senior users to the junior users, but that is fair to everyone. And the idea of the leasing market provides this opportunity to move water from the seniors to the juniors with some kind of payment that everyone agrees to. And so that's where this market idea comes through. So he's very supportive of that idea. He's just wanting to give folks more options. He's not, and the idea is that, you know, again, with a leasing market like this, it would be totally voluntary. If you don't want to participate, you don't have to. The other important thing and the key to the modeling here is also to understand third-party effects, is to make sure that someone who is not involved in that lease is not negatively impacted, okay? And so we're doing a lot of the modeling to try to understand which leases can occur without harm to others. And then, you know, you could go through your market and allow the water to move, and the state engineer is very interested. In fact, that's kind of one of the pillars of his AWRM program, is water leasing, not, you know, permanent transfers, at least in this case.
And we'll take time for one more question.
Hi, my name is Venkat Sridhar, and I'm wondering, how do you accommodate the uncertainty in your estimations, particularly on hydrology side? The other question is, are you using CMIP 3 or CMIP 5 for your projections?
Sure. I think for the last one, I think the CMIP 3 is what was used by the Bureau of Reclamation, if I'm not mistaken. I think it's the older data set. So that's what we've been using in this case, because we're working with the Bureau of Rec in those cases. As far as the dealing with uncertainty, that again is one of the nice things, at least in the cases where we're doing the systems modeling. Although we can't do the uncertainty interactively with folks, there's just too, you know, it takes too long to do those runs. We can do, you know, within a matter of hours, we can do those. And so, like with the case of the Rio Grande, maybe I didn't make this clear enough. So here you can see, so so we ran all 112 cases, the mechanistically downscaled models results, and so here you can see the average, or maybe the median of those cases, and then these different colors here represent the spread in the analysis. So this gives you the full kind of Monte Carlo analysis, if you will. And so from there, you can go and either look at the mean or whatever you want to look at and plan toward.
Okay, well, I'd like to once again thank you, Vince, for coming and talking to us. I found this to be a very fascinating topic, and I'm certainly going to be looking into what you guys are doing and
Thank you.
understand it better. I would like to just follow up with perhaps
Oh,
one
sure.
quick question. How successful do you think providing these modeling and gaming efforts have been in pulling the different segments of the water issue together to understand that they have to play well together?
Again, I guess I would say the results would be a little mixed in certain cases, and again, it gets back to the motivation. The Middle Rio Grande, I think we've had quite a bit of success. I think we've been having a lot of success with the ERCOT and WEC studies that we've been doing in several other basins. One basin where we have not had good luck, and it has been kind of problematic, is down in the Gila. And there again is one of the cases where the motivation is kind of split between the environmentalists who would like to see nothing happen, and then, you know, a lot of the irrigators and others who would like to see maybe some kind of project that would, you know, help them with their water demand. And so the motivation's not quite right, and so, you know, some cases I think it's just hard, so, to be real honest. The dialogue is there, so,
Okay,
Thank
well,
you.
thank you
you
again.
bet.